Another exponential. Again, you can actually use any base you want, but if you're being smart, I would say that a natural log is going to be a really good choice here because it will just straight up cancel out the e to the 4 minus x. So I'm going to try that. I'm going to leave a little room so I can show you if I use a different base what happens. Okay, so we're going to take the natural log of both sides. And on the left-hand side, that's going to wipe out the exponential. So the natural log of e to a power should just give me the power. 4 minus x equals the natural log of 11. And then I will subtract 4. And multiply everything by negative 1. Okay, so there's my answer. And this is a perfectly good and correct answer. I just want to sneak in over here, see if I can fit it. What would happen if I had chosen a different log? So I'm going to use common log. If I use common log, the first thing I would do is bring the power down to the front, since the log doesn't just cancel out the base. So even though I'm not getting that really nice clean cancellation that I got when I used a natural log, I did get the variable out of the exponent, which was my big goal. If you're trying to solve for x and x is stuck in the exponent, that's a problem, and logs will help you fix that problem. You could distribute here, but actually I think I'm going to go ahead and divide. The x is stuck in the parentheses. It's the one and only x, so dividing this will actually kill it all in one step. Often I make you distribute things in so you don't build fractions, but I think I'm okay with the fraction here. Log of 11 over log of e. And then steps are starting to look really familiar. Subtract 4. And multiply by negative 1. And you'll see what we get. Oh, hold on. Let me be careful. Multiply by negative 1, that becomes a plus 4. What we get doesn't look like the same thing we had before, but if you think carefully, it actually is. A change of base formula will confirm that it's the same thing. So if I wanted to take the natural log of 11 and change that to common logs, I would just go ahead and do it. So there's the common log of 11. And then I would divide by the new log of the old base. So common log, and the old base was e for natural log. So those are actually the exact same thing. Okay, last one here. If we have the natural log of 11x equals the natural log of x minus 5, my x's are stuck inside of natural logs, so I'm going to exponentiate using a base of e to try and cancel out the natural logs. Natural logs have a base of e, which means exponential base e is their inverse. Again, if you're comfortable, I don't actually have to see this in between step here. If you can see what's going to happen, it's all right to go ahead and just write it out for me. Basically, the only way that the natural log of 11x is going to equal the natural log of x minus 5 is if we can make 11x equal x minus 5. I'm going to subtract an x from both sides. So I get 10x equals negative 5. Divide by 10. X equals negative 5/10, which is negative 1/2. This was, oops, see if I can talk and write at the same time. This was a log equation, so I do need to double check. This is one of those non-optional checks. If I plug in negative 1/2 back in, I get natural log of negative 11/2. I cannot take the log, any log of a negative number, so this is actually not a good solution. You could check the other side if you want, and you'll run into the same problem. Basically, the only way to make 11x equal 5 minus x is if both are negative, in which case we can't plug either one into the log, so it's not possible to get the same thing out of the log. Because I had only one solution and I had to throw it away, I'm going to go ahead and say no solution. So no solution to that equation.